I've had a request to answer question 2 from your conservation of momentum, and I have just worked through it, and I'll quickly talk you through this. So this is the diagram for before collision. So there's only the bowl that's moving, the jack is stationary, and I've just put the speed and direction of the bowl, and jack has just got the mass. Okay, and then after collision, they're both moving at right angles to each other. So this is the after collision diagram. Okay, and according to conservation of momentum, the total momentum before collision equals total momentum after collision. Before collision, only the bowl is moving, so the total momentum is the momentum of the bowl, and the direction of the total momentum at the start is the arrow pointing upwards, vertically up, that way, in that direction. So here's the equation for total momentum. So the important thing is I've put direction for all the momentum. That's important. Okay, and so this is what I get. So 3.5 times 2.9, I get 10.15, and 3.5 times 1.4, I get 4.9. But when I make that the subject of the formula, I've got to bring this over to this side, and that's how I get minus 4.9. Now both these numbers are vectors. When you subtract vectors, you have to add the opposite. What's the meaning of that? The first number stays the same, including the direction. The minus sign becomes a plus, and the opposite means opposite direction. So what I do is I just draw a line that's parallel to the original line, and instead of putting the arrow on the top, I put the arrow at the bottom. Again, that's how I get this. So now you're adding these two vectors. Vectors are added head to tail. So this is my black line, that's the head, and then the tail of this joins the head of that, and the resultant always goes from start to finish. So that's the resultant, and that's the way the jack is going. And then in order to get what's the momentum of the jack, this is right angle, so there's your hypotenuse. So this one is 10.5 squared minus 4.9 squared, and you end up with 8.89, and that's the direction of the jack, which is the same as this. So they're the same there. Speed of jack after collision, momentum divided by mass is the speed, and then in what direction to the original direction of the bowl is the jack traveling. So I've just redrawn this triangle over here. They're the same, just indicating that's the original direction of the bowl. This is the direction in which the jack is traveling, so you want this angle. And then I just looked at this triangle for the values. So it's just sine inverse of 4.9 over 10.5, and you get 29 degrees. And so this one is what are the conditions. So over here, what are the conditions that must apply for momentum to be conserved? It's very well to say that there should be no external force, but what is your external force? Could be gravity, could be friction. How do you avoid gravity? It should be horizontal, because gravity has no horizontal component, and it should be moving on a frictionless surface. Okay, so I hope that made sense.